For today's video, guys, we are going to talk about section 2.2, which is about graphs. And specifically, we're going to talk about functions and domain and range of graphs. So to draw the graphs for a little while, we're just going to plot them by making some points and seeing what the shape turns out to be. So what I want you to start to think of a graph is a collection of points that make the equation true. When we solve equations, we're finding the number or numbers that make the statement true. Graphing is similar. We're finding a collection of xy points on a Cartesian coordinate system that make the equation true. So there are xy points that make this true, and there are a bunch of xy points that don't make it true, and we're going to find what they are. Okay, so we can graph the old-fashioned way just by choosing some x's and seeing the y's that go along with them. So I'll kind of get a variety and see what we get. I'm going to start with -10 and go to -5 and -1, 0, and 1, and 5 and 10 to start. If I need some more points to get more detail on my graph, I can do that. So at -10, when I plug in for x, I get -1/10, or -1/10. -1/5, -1. 1/0, that's a problem. That's undefined. All right, it's not 0, it's undefined, which means my graph will not exist at x equals 0. At 1, I'm going to get these same values again, just positives. So let's just plot these. At -10, I'm at -1/10. So when I'm at my furthest to the left, I am just barely negative. -5, I'm at -1/5, so I'm just slightly more negative because 1/5 is bigger than 1/10. -1, -1. So you can kind of get the idea, but you might need a little help. So I'm going to add in -1/2 and see what I get. -1/2, 1/-1/2 is -2. So when I go -1/2, I'm down 2, so I'm about right here. And that one point kind of helps. I connect the dots. I'm going to have asymptotes. All right, it's a word we'll use a lot. Asymptotes are lines on a graph that your graph approaches but never touches. So I've got two asymptotes already, the x and the y-axis, because this graph will never equal 0, and this graph will I'll never be allowed to have 0 on the bottom as well. All right, so those same dots on the other side, I'll just kind of quickly put those in place. We get the same deal in the top right. So this is the collection of all points that make it true. Not just the points I drew, but every point along this line makes it true. You know, all these points plugging in make it true. Some of them are nice, neat numbers. Some of them are decimal values that are harder to work with. But every point along either one of these lines makes the equation true. All right, so if I ask you what's a good definition of a graph on a quiz, you would want to say the collection of points that make the equation true. All right, so let's talk about a couple other topics. Domain. A domain is all of the x values that we're allowed to plug into the function. All right, another way to think of it was if you go from the far left to the far right of this graph, where does the graph exist? My graph goes on forever that way, so I don't have any problem down there. If I'm in all of this area of the x-axis, my graph exists until I get to 0. That's the one thing that I'm not allowed to plug in. So there's different ways to think of domain. Visually, it's where the graph exists, and we're talking about up and down, because up and down here, the graph doesn't exist at 0. I will never touch the graph if I move up and down. Algebraically, we're talking about numbers I'm allowed to plug in. So I can plug in anything but 0, because that's the only number that makes the bottom 0. Things that are going to mess up our domain are denominators being 0, square roots being negative, And then when we get into trigonometry later, we'll have some domain issues there. But for now, watch for denominators and square roots. Never let a denominator be 0, and never let a square root be negative. So to add to our graph, all real numbers except 0. You could just say x is not equal to 0 is our domain. All right, it's everything but. Now, range. If you've plugged in all the x's you're allowed to plug in, range is the y's that go with those. So visually, you would move from bottom to top, and you would say, okay, if I am at this height, does my graph exist at that height? Yes, it does. It's right there. Does my graph exist? Yes, yes. I keep crossing my graph with these horizontal lines. When I get up to y equals 0, I'm not touching the graph because that's an asymptote. All right, so range is y is not equal to 0 for this case. But it is all the y's that result in the x's. All right, so let me get those definitions. A domain is all possible x's, and a range is all resulting y's. All right, so some of the questions in this section will give you a picture of a graph and say, what's the domain and range? Some of them will give you a domain and range and have you draw a picture, but that's what domain and range mean. All possible x's and then all resulting y's. Now, sometimes they might make up the domain for you. We assume that the domain is all real numbers, but some of the graphing they ask us to do is domain restricted. They'll just give you a couple numbers to plug in, or they'll say it's only these digits, or they say it's only positive numbers. So let's try a little variety here. What if your function is y equals x squared plus 1, and your domain is negative numbers? So x squared minus 1, that's going to be the graph of a parabola. It's shifted up 1. However, I'm not allowed to plug in any positive numbers. I'm only allowed to plug in negatives. So I can't plug in 0. I can only plug in positives, or excuse me, negatives. X squared plus 1, by the way, would go through 0, 1. It would go through 1, 2, and negative 1, 2. It would go through 2, 5, and negative 2, 5. So 3, 4, 5. That's about all the space I've got. If you didn't have that restricted domain, here's the graph. However, since they restricted the domain to only negative numbers, we're going to have to adjust the graph a little bit. This over here is no longer part of the graph. You can kind of leave it dashed to show that, you know, it was part of the graph until we restricted the domain, but it's not part of the graph anymore technically. So it's better completely gone than it is drawn in there, but if you want to leave it dashed, it's not going to hurt anything. So there's my graph. And the open circle, just like when you're graphing an inequality on a number line, that means we go all the way up to, but not to, the point 0, 1. All right, so the point negative 0.00001, and then whatever that y value, that is included, but the 0.01 is not included. All right, so they gave me the domain. What's the range? The range is the y's that are resulting from the x's I was allowed to plug in. So where does my graph live if I look horizontally? Does it live down here? No. Does it live down here? No. I can't hit my graph moving side to side anywhere down there. How about right here? No. What about when I get to 1? Is 1 allowed? Will my graph ever give me a value of 1? If I were allowed to plug in 0, then yes, that's the cutoff point. But since my domain is negatives, I'm not allowed to plug in 0. So my range starts at 1, but 1 is not included. Okay, so range remembers in terms of y. Y is greater than 1. Y is not greater than or equal to 1 because of my open circle. So a lot of parallels between number line inequalities that we've been graphing, and then domain and range. So that's going to about wrap it up for 2.2. This is, you've done some graphing before just by choosing points. We're not doing anything much fancier than that, but I want you to start keeping in mind the words domain and range. Those are going to be important words for us throughout, really, for any of the math you do from here on out, domain and range. All right? So I'll see you in class. Have a good one. Young out.